Hey there, you rates. In this video here, we're going to be looking at exercise 4F, which is to do with area of circles. Now, in this one, there is a formula that I'm adding on that's not in your textbook, which has this component. Normally in your textbooks, the area of a circle, the formula is pi times the radius squared. And remember, the radius is in a circle from the center of a circle all the way to the side, so about half of a diameter there. This is called the radius. And if you square that number and then multiply it to pi, that usually gives you the area. However, what they don't normally tell you is that formula right there is pi r squared is only used mainly for full circles. And this missing part here is what it doesn't explain. Well, why is that a full circle? So here, let's look at the formula here. We know that r here is the radius. So you square it and times pi, which on your calculator, make sure to find the symbol pi, unless they ask you to use the approximate value, which is 3.14. Then you've got this component in yellow that I've highlighted here. This symbol is called theta. Okay, so theta degrees, and it represents the angle of the circle that you're interested in that covers the area. So for example, I may only want this portion of a circle. So I may only want 37 degrees. So that means this part of the circle is the area that I want rather than the full circle. See that? So this other section that I'm dotting, this section here, I don't want as part of a circle. What if I only just want this portion and that angle is 37 degrees out of the entire full circle? And that's what the angle represents. Okay? So you always got to look for the angle that the area that you're interested in is. So note, partial circles are known as, and there's a name for it, when you're finding the area of partial circles, so area of partial circles are known as sectors. Okay, fill that in. And that symbol there was called theta. Now, let's do an example here. Example 1. So say you're not looking for the area of a full circle, but you're now looking for the area of part of a circle. So you can see in this example here, they want you to correct the answers to one decimal place. But can you see that if I were to draw a full circle, if I followed this would have been the full circle. And obviously the radius, which is from the center of the circle to the side of the circle, this is 5 centimeters. So I know the radius, r, must equal to 5 centimeters, right? But the area that I want is not a full circle. I only want a portion of it. See, that portion in yellow is only 140 degrees out of the full circle, which normally is, hopefully we know that a full revolution is 360 degrees. So I only want 140 degrees of the 360. I don't want the full 360. And that's why in your formula, what changes is that I know the radius is 5. I know it's pi times radius, which is normally pi times 5 squared. That should give you the area of a full circle, but I don't want a full circle. What I want is I only want 140 degrees out of a total of 360, because 360 is a full circle, right? So I don't want the full circle. I only want 140 out of 360. Now, depending on your calculator, you can, if you have one of those green calculators, you can actually just type in the fraction 140 over 360, and it simplifies it for you. So in my case, it's 7 on 18. But if you don't have one of those calculators, that is fine. You can actually just type it all in one go. So you can go to your calculator, find the pi symbol. So mine's just down here. Pi times, and it was 5, square it, times, and if you're using one of those scientific calculators without a fraction button, use the brackets, press brackets, and we want 140 divided by, so press the divide symbol, 360. So that just means the same thing as saying 140 over 360. So 140 divided by 360, and that's the portion that you want. And when you press enter, remember you're writing the full answer here, which is 30.5433. So I'm going to write here, it is 30.5433. Don't forget the units, it's squared centimeters. But we want to round it to, or correct it to one decimal place, so your answer is actually 30.5 squared centimeters. Okay. Don't forget your units. I've been looking at some of your homework and I noticed that you have not been putting in your units. So when it comes to an assessment, if I don't see units, you will be penalized for it as well. Let's do the same thing for the next question. So the next question, again, we can see that had I had the full circle, it should have looked something like this. That would have been the full circle, right? Now, not quite, but let me just see if I can make it a bit smaller just to make it kind of look like it fits. Kind of there. Yeah, you get the idea. That would have been the circle, but we don't have that portion that we actually want. What portion do we actually want again? Can you see right here? This is the portion we want. And how do I know that? Well, if you look at the diagram, what I've just colored, that is the portion that you're interested in. So it's not a full circle that you're looking for. And what's deceptive here is that they say this is 120 degrees, but that 120 is on this side. So it's actually this side here that's saying that's 120, but the area that we want is on this side. So you need to actually work out what the angle would have to be first. So you already know the radius, r is equal to 7. So that's cool. It's pi times 7 squared. But what's the angle that you want out of 360? Well, out of 360, you need to work out what this portion is. So 120 plus what will give you 360, and hopefully you worked out it's 240 degrees. Okay, or if you didn't know, on your calculator you can do 360 take away 120, and you'll get your 240 degrees there. Okay, so I know that I want 240 degrees. That's this area on this side here. 240 degrees will give me the area I want in yellow. So I'm just going to quickly do that. So it's 240 out of 360. Type it in your calculator. You can do it all in one go. 240 over 360. And here we go. I'm going to do it all in one go. So pi times 7 squared times 240 over 360. I'm missing 0 there. And the answer is 102.625. So 102.625. Don't forget the units. It's in meters, so squared meters. And rounding to one decimal place makes it 102.6 squared meters. Okay, so that's what today's exercise is to work on finding area of sectors. And sectors just simply mean a portion of a circle, or partial area of a circle. Let's have a look at some problem-solving ones here then. This one here looks a bit more tricky, but again, to find the area of the shaded region, you got to do a bit of problem-solving here. I can see this is the region I want, but I can actually see two shapes here. I see that there's a rectangle. See, this is a nice full rectangle. So if I got the total area, that's too much now. See, there's a portion I don't want. It's that white region there that I don't want. I only want this section. But if I find the area of a rectangle, which I know is length by width, okay, so length times width will give me the area of a rectangle, and then I minus this portion. If I minus that portion there, we'll notice this is actually part of a circle. That's technically a portion of a circle, and it's 90 degrees here. So part of the circle, as you can see there, if I just find the area of this portion of the sector, which is 90 degrees, well then this is a circle, and the area of a circle is pi times radius squared, right? But then it's also times 2. Well, I only want 90 degrees of the 360. The question is, what is the radius? What is the radius? And hopefully you can see if I drew the full circle, the radius is clearly from here to here is a radius, or from here to here is also the radius as well. So we know that a radius must be 10 millimeters. So answering the question, let's put it together. Length times width. Length is 20. Length is always the longer side. Times 10 will give you the area of a rectangle, which we know is 200. Minus pi times, and our radius is also 10. So 10 squared times 90 on 360. So here, let's work it out. What's 200 minus, what's that? Pi times 10 squared times 90 on 360, which is 1/4. And it gives you 78.5398. So 78.5398 398. I normally don't write as decimals. I actually normally do it all in one go on a calculator so that I don't get... Because if you round too early, if you round it to only 4 decimal places and there are meant to be more decimal places, you'll just be slightly off. So don't get in the habit of rounding early in your calculations. Only round at the very end. So what I'm trying to say is on the calculator, a better method to do is you should have done 20 times 10, that's the rectangle, minus, and then I'm just going to do this separately, pi times 10 squared times 90 on 360. So that's the circle. See how I've done it all in one go? So when I press enter now, this is a much better answer, which is 121.46. It's 121.46, and rounding that to 1 decimal place, don't forget your units, it's squared millimeters, is 121.5. Because the 4 is 1 decimal place, but the number next to it, the next digit is 6. It's 5 or more, so you round the 4 up by 1. Okay, so you can see that I was problem solving, took the rectangle, total area minus the circle, or quarter of a circle. I should write here quarter of a circle. Quarter circle. All right, let's do the next one, and this is the last example here for today. Let's have a look here. You've now got this region. This is the area I want. Can you problem solve this? Now, I already put a hint here. I said big semicircle, which means this one. This is a big half circle. So I can get a total area for the big half circle, but then there's a region I want to remove, which is another small semicircle inside. So here, that means if I can get big semicircle minus small semicircle, I should be able to get the region I want. True? So let's work it out. Well, big semicircle, the area of that would be pi times radius squared, but semicircle just means half of a circle, so it's 180 degrees out of 360. 180, I'll just write that again, 180 over 360. Minus, and same thing again, the small circle is also pi times radius squared times 180 on 360. The only difference is that they both have different radius, or radii. So the small one, clearly from here to here, has a radius of 60, right? So I know the small one is pi times 60 squared times 180 on 360. Whereas the big semicircle is the big one, has a radius of 60 plus 60, which is 120 squared. So on my calculator, I'll be doing pi times 120 squared times 180 on 360. But we know that 180 on 360 is actually half, right? So I'm going to type it on my calculator here. It's actually pi, pi, let's do it. So I'll do in brackets here, pi, so big semicircle is pi times 120 squared times half, okay, because 180 on 360 is half. So that's the big one, minus the small semicircle. It's pi times 60 squared times half again. And that gives me a total answer of 169.64.6. Okay, 100, what? Oh, no, not 100. That's 16,964.6 squared centimeters, but rounding to 1 decimal place, which actually it already is. So the answer is still 16964.6 squared centimeters. There you go. That's exercise 4F from memory. Yeah, 4F. Okay, hope that helps you. But yeah, the only part of this formula that is not in your textbook is that portion of that circle that I want you to understand. Okay.